Hello friends, let's learn with fun. I am Themreirin Varah. Today we are going to talk about the first chapter of Class 10 Mathematics, which is real numbers. But before we move on to the main content of the chapter, we shall see certain basic concepts on real numbers which will be beneficial for the proper understanding of the entire content. So we shall cover types of numbers, factors and multiples, prime numbers and composite numbers, factorization, and variables, literals, and constants. Let's get started. So what are numbers? Numbers can be roughly defined as a tool or an instrument that I use to represent the value of something. It could be a concrete object or an abstract object as well. For example, the distance between your home and your school is indicated by numbers. Your height, your age, the amount of pocket money you get are represented by numbers. Alright? Now numbers can be broadly classified as real numbers and imaginary numbers. Imaginary numbers are those numbers which we may not have come across till now, but you will come across in your higher classes, and these imaginary numbers are used for solving complex mathematical and scientific problems. But in our textbook, we are not interested in imaginary numbers. What we're interested in is real numbers. Now, real numbers can be further classified as irrational numbers and rational numbers. But before we look at the definition of what rational number is, we shall try to look at some of the basic types of numbers that we have already come across. The first one is natural numbers. Natural numbers are all those counting numbers, the numbers that we used while counting something. So it starts from 1, 2, 3, 4, and so on till infinity. Alright? Now, the second type of number is whole numbers. Whole numbers will include all the counting numbers starting from 1 till infinity, as well as 0, and this 0 will represent nothingness. Okay? And the third type of numbers, called integers, contains both positive and negative counting numbers. Alright? All those numbers which are greater than 0 are positive integers, and all those which are less than 0 are called negative integers. Okay, and 0 is a neutral integer. Now let's define rational numbers. Rational numbers are those numbers which can be written in the form of one integer upon another integer, such that the denominator is not equal to 0. Let's take an example. 6 can be written as 6 upon 1 or 12 upon 2, and you will see that the numerator is also an integer, denominator is also an integer, and the denominator is not equal to 0. Therefore, 6 is said to be a rational number. Similarly, take the example of -3. -3 can be written as -3 upon 1 or -6 upon 2, and so on, and you will see that both the numerator and the denominator are integers, and the denominator is not equal to 0. Therefore, -3 is also a rational number. Now, what about some decimal representation of numbers? Let's take 1.5. It can be written as 15 by 10. So obviously it is in the form of rational numbers, so it is a rational number. Similar case with 0.325. It can be written as 325 by 1000, which is in the form of rational numbers, so 0.325 is a rational number. Similarly, the third one is also a rational number, and you will see that all of these three numbers have terminating decimal representation. Therefore, for any decimal number whose decimal places terminates, then all of them are rational numbers. Now let's take √2. Can √2 be written as some integer upon another integer? No, because when you write √2 as √2 is upon 1, then √2 is not an integer. So √2 is not an irrational number, which we will prove in our succeeding videos. Now, what about a decimal number whose decimal place does not terminate? Then two cases arises. One case is in which the digits after the decimal point are non-repeating and there is no pattern whatsoever. And there are those whose numbers after the decimal point are repeating and shows some defined pattern. Those numbers which are non-terminating and also the digits after the decimal point are non-repeating, then what can we say about these non-terminating numbers? I have made a table for you here to understand which are rational numbers and which are irrational numbers for decimal numbers. All terminating decimal numbers, whether they are repeating or non-repeating, are all rational numbers. But if the decimal number happens to be non-terminating, then it would be rational number if the numbers or digits after the decimal point are repeating, and it would be irrational number if those numbers are non-repeating. Okay, now as we have seen, natural numbers, whole numbers, integers, you will find that all of them can be written in the form of rational numbers. Therefore all of them are rational numbers. Okay, and whatever number is not rational are called irrational numbers. All right, now let's look at fractions. Let's take 5/9. 5/9 is already in the form of some integer upon another integer, and this denominator is not equal to 0. Therefore it is already a rational number. So we can say that and moreover 5/9 is a pure fraction. Okay, and so this is a rational number. Now let's take a mixed fraction, 2/1/5. And 2/1/5 can be written as 11/5, and you will see that this is also in the form of a rational number. So all fractions, whether pure or mixed, are all rational numbers. Okay, now we shall look at factors and multiples. What is a factor of a number? Factors of a number are all those numbers which can divide the number. Let's take the example of 12. 12 can be divided by 1, 2, 3, 4, 6, and 12. Similarly, for 18, the fractions would be 1, 2, 3, 6, 9, and 18. Okay? Since all of these numbers can divide 18. Okay? Now, highest common factor. What we're interested in is the word common and highest. Now, when we say common, we are going to find common factors between either two numbers or more than two numbers. Let's take the example 12 and 18. What are the common factors here? 1 is a common factor, 2 is a common factor, 3 is a common factor, and 6 is a common factor. And among these common factors, the highest of them is 6. Therefore, we can say that HCF of 12 and 18 is 6. Okay? Now we shall look at multiples of a number. Multiples of a number are all those numbers which can be obtained by multiplying the number by a positive integer. So multiples of 4 will be 4, 8, 12, 16, 20, 24, and so on. Let's take multiples of 6. So 6, 12, 18, 24, 30, 36, and so on. And now let's look at what lowest common multiple is. Once again, the important words are common and lowest. Now LCM will be found for 2 or more numbers. Let's again take the example of 4 and 6. What will be the LCM? So first of all, let's pick out the common multiples of 4 and 6, which are 12, 24, and even 36. Okay, and many more. But we are interested in finding only the lowest common multiple. Therefore, the lowest among them is 12. So LCM of 4 and 6 is 12. Okay. Now moving on to our next topic, which is prime numbers and composite numbers. Let's take 12 again. The factors of 12 are 1, 2, 3, 4, 6, and 12. You will see that there are 6 factors. Whereas if you take 5, you'll find that it has only 2 factors, 1 and 5. So such numbers which has only 2 factors and they are 1 and the number itself, then such numbers are called prime numbers. So 5 is a prime number. However, if the numbers have more than 2 factors, then they are called composite numbers. Okay, some of the examples of prime numbers are 2, 3, 7, 11, 13, 19 and so on. Now what about 1? Is it a prime number? Now 1 has only one factor, which is 1 itself. So this does not satisfy the condition that a prime number should have 2 factors. Therefore 1 has only one factor. Therefore 1 is not a prime number. Okay, all those numbers which are not prime numbers, that means which has more than 2 fractions, are called composite numbers. In our example, 12 is a composite number. Other examples are 6, 9, 10 or 4 are all composite numbers. Alright, and one thing we must remember, that when we're talking about prime numbers, composite numbers, factors and multiples, we're concerned only with positive integers. Okay, this does not apply to negative integers. Okay, now we shall look at co-primes. What does it mean? Let's take 6 and 7 and find their factors. So 6 can be written as, the factors of 6 are 1, 2, 3 and 6, and those of 7 are 1 and 7. And we will see that the common factors between 6 and 7 is only 1. In that case, we can say that 6 and 7 are co-primes. So when you say two numbers are co-primes, they have a common factor, they have only one common factor, and which is 1. Alright, all pairs of prime numbers will make up co-primes. Okay, but what if the pair also contains a non-prime number, or that is a composite number, whether it will be able to form a co-prime or not? Let's take the example of 5 and 9. Yes, 9 is not a composite number, but 5 and 9 has only one common factor, which is 1. Therefore they are also co-primes. Okay, now the next topic is factorization. Let's again take the factors of 12. Now if 12 is written as product of its factors, 12 is written as, let's say, 2 into 6. Okay, it can also be written as 1 into 12, or 3 into 4, or even 2 into 2 into 3. Then that is called factorization. So factorization is the process of writing a number as product of its factors. Okay, and when the factors that you use as product to form the number are all prime factors of the number, then such factorization is called prime factorization. Alright, so in this case 2 into 2 into 3 uses only the prime factors of 12. Therefore this is the prime factorization of 12. Okay, now we shall see variables, literals and constants. Constants means whose value does not change, and so all real numbers are all constants. 5, the value does not change, so 5 is a constant. Now what about variables? Variables are unknowns. You don't know the value of it, so it is subject to change. Its value can change depending on the condition. So variables are unknowns and their values vary, and in order to find the value you need conditions. Okay, how we will use conditions to find the value of the variable, we shall see that in our succeeding videos. Okay, now how are variables represented? That is the question. Variables are represented by what we call literals. These literals are simply letters of the English alphabet. It could be in small letters, or it could be in capital letters starting from A to Z. Alright, we can use any of these letters to represent the variables. So we normally use X, Y to represent unknowns, right? Now there are two concepts that I would want you to know. The first is literal constants. Literal constants, by the name itself, are unknowns and will be represented by English alphabet, but their value does not vary even though you don't know it. For example, the distance between Delhi and Mumbai. It does not change. It remains constant, but you don't know the exact value. So whenever you have to represent that distance in your mathematical calculation, then you can simply represent it by a literal, let's say A or B, and the value will not change. All right. Now general variables. General variables are also unknowns. These literals, these unknowns are not interested in getting any specific value. Okay, they are meant to represent a general formula or a general identity, or also they give a general expression to something, and the values does not matter. We don't need to find its value. Okay, but rather we can input any value on them as and when we need. So friends, that is the end of today's video. From the next video onwards, we shall start the main contents of the first chapter, which is real numbers. So please like and share this video, and don't forget to subscribe to my channel. I will see you in my next video. Until then, keep learning with fun.